Today we will be going through deploying PostgreSQL on Linux securely and show some practical hardening steps that you can apply in the production. PostgreSQL is a powerful open source relational database that's used across many applications because it often stores sensitive data. So in this presentation we'll cover installation, key configuration files, authentication, encryption, and 3 core hardening recommendations. Secure authentication and access controls, network/TLS hardening, and patching with auditing and monitoring. I'll also provide some real-life commands and configuration tips that can be used immediately. PostgreSQL is an ACID compliant open source relational database that supports complex queries, transactions, and a wide range of extensions. It is commonly used for web apps, analytics, geospatial workloads, scheduled tasks, and more. Its extensibility and standard compliance makes it popular in both startup and established enterprises. Because it often stores very critical data, misconfiguration or a lack of hardening can result in severe data breaches or availability issues. Installing PostgreSQL is straightforward but can vary by distribution. On Ubuntu, the typical steps are sudo apt update and then sudo apt install PostgreSQL. On CentOS, you could use a sudo dnf install command and then initialize the database with a setup command if required. After the installation of PostgreSQL, you would want to enable the start service with sudo systemctl enable. Note that this package name and default data directories can differ by version or distro. So always check documentation for your target version. In regard to configuring files, the two primary files to know are PostgreSQL.conf, which contains the main server settings, and then pg_hba configuration. This is the host-based authentication file. On different systems, these could be under different file names, and they define which clients can connect and which databases and users and which methods to use. So properly configuring both is central to security. Network exposure for PostgreSQL is one of the biggest risks. So in the configuration file, you would want to set the listen addresses to only the interfaces you would need. For example, localhost for local only, or a single private IP for application only. You can also avoid listen addresses. So you can also use a firewall such as UFW or IP tables to restrict access to port 5432, so that only app servers can reach the database. You would also want to enable SSL/TLS for client connections in the configuration and point to your certification and key files. You would never want to expose port 5432 to the public internet. You would want to use roles to model application and human access. You can create distinct roles for each application component and grant only necessary privileges. For example, a web app may only need the connect and select/insert commands, and you can avoid granting super user or other high escalated roles. You can rotate credentials regularly and store them in a secrets manager rather than a plain text file. Connection pooling with PG Bouncer also helps control the number of database connections and can reduce the attack surface by centralizing authentication. Hardening recommendation 1 is for secure authentication and access. You would want to lock down authentication access by enabling SHA-256 for all password-based logins, and you can migrate existing users using the SHA-256 command. Hardening the HBA configuration to limit connections by database, user, and client IP ranges, as well as removing any trust entries to avoid local socket exposure unless needed. After making these changes, you would reload or restart PostgreSQL and validate it with test connections. Hardening recommendation 2 is for TLS. You would want to secure networking and limit listen addresses and place PostgreSQL behind internal networks or a VPN. You can use firewall rules to block public access to port 5432. You would want to enable SSL/TLS on the server and require clients to use TLS. Where possible, you would want to enforce TLS versions with client libraries or connection parameters. For any cloud deployments, you would use a VPC and security groups to restrict access. For an on-premise, you would use a VLAN and network ACLs. If you have to have remote access, consider the SSH tunnels or a dedicated proxy. The third hardening recommendation is to maintain vigilance with patching and visibility. You can subscribe to PostgreSQL and OS security advisories, which allows you to apply patches promptly. You can enable comprehensive logging in the configuration file, and you do this to capture important events. You can use PG Audit to record detailed activity if you need fine-grained SQL auditing. You would want to forward the logs to a centralized SIEM stack and set alerts for suspicious actions, as many failed logins or unusual data exports. You could also consider fail to ban command to block brute force attempts. Some other important hardening steps can include tightening the file system permissions. The data directory must be owned by the Postgres user and have restrictive permissions. You can also disable or remove unused extensions to reduce attack surfaces. Using role-based maintenance accounts for backups and never embedding credentials in application source code is another good idea. You can use a secrets manager for database passwords and rotate your keys regularly as well. Backups are your safety net and they must be secured properly. You can use PG_base backup or a logical backup like PG_dump to ensure that backups are encrypted before placing them in storage. You also want to protect WAL archives the same way. You should test restores regularly. A backup is only useful if you can restore it. Restrict access to backup storage with IAM or ACLs, and log all backup and restore operations. You also might want to consider immutable backups or versioning to protect against ransomware. In summary, PostgreSQL is feature-rich and suitable for production workloads, but requires deliberate hardening. You want to prioritize secure authentication, network controls, patching and monitoring, and secure backups. Additional practices like file system permissions, secret management, and testing restores complete the whole picture.